channel Mukesh Tech Up. So from this previous part, the part 1 and part 2, we have seen the convolution neural network architecture and we have pre-processed the data. So now let's go ahead and we can define our CNN and we will train it, right? So let me recap the architecture which I'm going to use. Let me comment it. I'm just going to use this convolution layer, okay? Then max pool layer, right? Followed by again convolution layer, then max pool, then I'm going to use the flatten, and then I'm going to use dense. Okay, so this is the architecture which I'm going to follow. So let's jump in and we will define the model. Okay, so let's use the variable name as model equals to. So you already seen that I have imported the required library for the TensorFlow, right? TensorFlow. So now what I have to do, let me zoom in little bit. Okay, so model equals to, let's say, tf tensorflow dot keras dot sequential. So here sequential represents all the layers would be in the sequential fashion, right, one by one. So we have to add one layer. The first layer is the convolution layer. So this line represents to this first step, tf dot keras dot layers dot conv 2d, right? Because we are using the two-dimensional data, so I'm using this conv 2d. And if you will press shift and tab, it will show you the required parameter for this one. So it says the filters, and we can say some generally we call kernel as the filters, then kernel size, then few are optional, okay, and the activation function, right? So let me define. We are using the kernel, this filter as 50, right? Kernel size which we are going to use by 5 by 5. Then let's say activation equals to, we are going to use ReLU activation function, right? Rectified linear unit. Then the input shape, input underscore shape would be, in our case it's 28 by 28 by 1. Why this is 1? Because we are using only the grayscale. So the density of this grayscale would be 1, because it's not in the RGB, red, green and blue channel. So if it is case of RGB, then we have to define 3 instead of 1. But as of now we are using only grayscale, so I'm just putting it 1, right? So this is the very first layer, this conv layer. Now after this conv layer we have to define the max pool, right? So similar to this one, what we have to do, tf dot keras dot layers dot, let's say, max pooling 2d, right? Max pooling 2d. And let's see the parameters for this one. It says pool underscore size, right? So we have to define pool underscore size equals to 2 by 2. We are using the pooling size 2 by 2, right? So what it will do, it will put that filter on the input data and it will get the required feature from the input image and it will create a feature matrix, right? So what I said here previously, if you will see the architecture, first one is the convolution layer, next one is the max pool, then again convolution layer and max pool. So what we have to do, let's do a copy and paste here for the next layer. But instead of, here you will see the input shape is not required here, right? Because input is the first step that goes to the first layer, right? So here input is not required, so we will just remove. Now let me remove this one, input underscore this one, right? And activation equals to value. Okay, now the filter size or the kernel, we will use 3 by 3 here, right? And all parameters are good. tf.keras.layer max will 2d pool size 2 by 2, right? Now let me add the flatten layer. So you can see up to here we have done, right? These four steps we have done. Now we have to add the flatten layer. So for adding the flatten layer, tf.keras dot layers dot flatten, and no need to provide the arguments here, right? After this flattening, what we have to do, we have to add the dense layer. So let me add the dense layer, tf.keras. So guys, here you will see I'm just following a very simple nomenclature, the writing the Python code. There is even advanced way also. Instead of writing every time tf.keras.layers, instead of that we can use the add when we will assign tf.keras.sequential to a variable, and directly we can use that one. So just to make you better understand on this one, let me do tf.keras.layers dot dense, right? And this is the output layer. So we because we are using the output as 0 to 9, right, for the prediction. So let's say 10, right? So if you want, we can apply the softmax activation function here just to achieve the non-linearity. So this is very very important. What is non-linearity? If we are using the linearity and we are not using any activation function, then the output of a neural network would be the linear combination of this input, and it won't provide the required output. So activation function is the more and more mandatory part, right? Now this is done. Let me, what is that sequential, what it says, name value is not defined. Yes. So for this one, I have to put this one, right? Got it. Now let me do a model summary here. Model dot summary. You will see it's convolution 2D, right? The first parameter is none, right? Because we can't, input goes as a batch size, and we can't show, and I can't make you sure like the what would be the first input, right? So that's what it coming as none. And the size of this one, 24 by 24 by 50. Total required parameter are 1300. So if you will recall, I mentioned earlier like the second layer configurable parameter would be higher compared to the first one, and you can see here this is 22,550, right? And you can see it's decreasing gradually, right? Not very fast. So that means model is good, and this trainable parameters are 36,360. Now we have just defined this layer, and after that we have to write some loss function and some matrices. So for defining the loss function in general, our model needs to output probabilities of each class, right? So which can be achieved with a softmax activation in the last dense layer. This is the dense layer, right? So here we can apply the activation function. However, when using the softmax activation, the loss can rarely be unstable, right? This is very very important. So when using the softmax activation, the loss can, or it could be unstable. So instead of incorporating the softmax into the model itself, we use a loss calculation that automatically corrects for the missing softmax. right? So what we have to do, let me add some comment and define loss function. And what we have to do, loss underscore fn equals to tf dot keras dot losses dot, and we are going to use sparse categorical cross entropy, right? Sparse categorical cross entropy, and I will say from logits equals to true. So why this from logits equals to true means, if we will do it true, that means it will include this loss function to the activation function to the loss function itself, right? Let me repeat it again. When I will do from logits equals to true, that means it will add the activation function to the loss function itself to correct it, right? Now let me execute this one. Now we have to compile the model. Compile the model. For compiling the model, what we have to do, model dot compile, and we have to see the parameter. It says optimizer, right? What all are the parameter? Optimizer, loss matrices, loss weights, weighted matrix, right? So the required parameter is the optimizer. So optimizer equals to, we are going to use Adam optimizer, and loss underscore fn, and loss equals to loss underscore fn. Already we have created this function, right? And matrices equals to, we are going to use, we are going to use accuracy, right? So here I used optimizer as Adam, it's Adam, and loss equals to, I wrote this loss function which includes the activation function itself, and matrix equals to accuracy, right? Now there is a one important thing here, that is called as callback. What is callback? Suppose if we are training a model, right, and model is decreasing its performance, so on some certain limit or certain points the model itself should stop, and just to prevent the overfitting, right? So we have to define early stopping. Okay, so let's say early underscore stopping equals to tf dot keras dot callbacks dot early stopping, right? And here if you will see the arguments, it says monitor equals to well loss, minimum delta equals to 0, and patience, verbose, mode, and so these are the required parameter. Okay, so now let me start adding one by one. So monitor equals to well underscore loss, mode equals to auto, yes, because automatically it should take care, and min underscore delta, right, it was 0, and patience equals to 2, then verbose equals to 2, 0, yes, for every, after every epoch it should print, and restore best weights equals to, so this is the early stopping function which I will be using. So I have defined some set of parameters, right? So it says mode equals to auto. So whenever the accuracy decreases, automatically it will trigger and it will stop. Now we have to train the network, right? So we have defined the layers, we have created the model, compiled it. Now we have to train the model. So train the neural network, CNN, right? So for training it, what we have to do, model dot fit, right? In this one, model dot fit, it takes some parameter, train underscore data, right? Epoch equals to number of epoch. So on the top of this file I have defined this static constant variables, number of epoch equals to 20, right? Then let's say callback. So callback equals to it was early stopping, right? Validation underscore data equals to validation underscore data, and verbose equals to 2, right? Let me execute this cell. Okay, sorry, it was my mistake. So based on your laptop configuration, if you are using the GPU, speed would be very fast. If you are using the normal, it will take some time. So it says epoch 1 started by 1. Out of 20, it's executing the first one, right? So let's wait and watch the how many epochs it's going to execute, and I will tell you what does that verbose 2 means here. This verbose 2, right? And it's taking the callback as early stopping, and that is auto when the accuracy decreases after the two subsequent. So patience equals to 2 after the subsequence 2. So it says for the very first epoch, it says accuracy equals to 92%, and the loss is 0.068, and the total validation accuracy is 97%, right? So let's see for the second one. And after completion of this one, we will test we will test our model, and I will show you the output. For the second one, it says accuracy is 97% and the validation accuracy is 98%. So it's taking the training data. Already we have defined on top of this one. So you will see this train data and the validation data, right? So model is training on training data and the validation happening on validation data, and we will test on the test data. So I think friends, every step is neat and clean and it's self understood, and make sure you are doing the practical by referring this file, and you will understand the every and each component of the convolution neural network. And mentioned this bracket here for putting this early stopping. Right? If sometime we are just drawing the plotting the graph for the prediction, and we are using the tensor board, and some other callback function are also required in this model not fit part. So that time we can write those callback function here, but make sure early stopping should be the last one. It should not be at the first place, otherwise it will give throw the error. So far we have seen it was 99%, then 99.35, 99.08. So guys, you can see clearly here from these last two, right? It was 99.50. From 99.9950 to it came to the 0.9935. Then again it came to the 0.9908. So after the two, it says y was equals to 2. So after the two, it is stopped automatically. Mod equals to auto. So if loss is decreasing, okay, so it is stopping here. Now this time testing our model, right? Okay. So for model testing, let's say model underscore evaluate, and we have to provide test underscore data, and it will return evaluation. So let's say test underscore loss, comma test underscore accuracy. So this evaluation, it will give the loss and accuracy. So you can see loss is 0.03 and accuracy is 0.98, right? Now let me plot these results so we can clearly visualize the results. So let's say plotting the images. So for plotting the images, let me import matplotlib dot pyplot splt and import numpy as np. These are the two required libraries, numpy for some numerical operations and pyplot plt as for plotting the graph. So the test data which we have to split into the two arrays, right? Why? Because the test data which we see, it contains the images and labels. So what we have to do for images, LAVEL, images comma labels, right, in test underscore data, and from here we will take the first one, right, and let's say images underscore test equals to images dot numpy. Why this numpy? Because we are converting it to an array, right? So that's what we are doing this numpy. If your input is already converted to the array, then no need to do this one, right? And labels underscore test equals to labels dot numpy. Labels is not defined. Okay, labels, right? It was a typo mistake. Now what we have to do, we have to reshape the images, right? So np dot reshape images underscore test, it should be 10,000 28 by 28, and let me hold it to a variable images underscore plot. So what I have done here, I just separated this images labels from this test data just to plot it, right? And now we have to write one function, some code to display the image, and we have to test it. So let's say I equals to 1. Now what we have to do, we have to plot the image plt dot figure, plt.figure, and we have to define fixed size equals to, let's say, 2 by 2. Okay, plt.axis equals to, let's say, of, okay, and plt.imshow, we have to provide the images underscore plot. All right, and because our index range, it's starting from 0, so let's say I minus 1, right, comma, c map equals to, let's say, gray, and aspect equals to auto. So guys, these are the some different normal parameters. Just do a google and you will come to know when you will study about this pyplot library, matplotlib, right? And plt dot show, right? This will show, but for printing the correct label for the image, let me write one print function also. So let's say label, right, dot format, dot format, right? What we have to pass, labels underscore test, and it should be I minus 1, right? What it says, format value error. Okay, I equals to, I took 1, and plt dot figure fixed size equals to 2 by 2, axis of plt dot im show images plot I minus 1, c map equals to gray, aspect equals to auto, plt dot show. Why this value error? What it says, say color map or string or none. Gray is not valid value. Okay, so sorry, it was my mistake, it should be gray. Okay, so on the first index you will see the label is 2, this digit is 2, let me do is 11, so it's 8, right? Now let's say 1110, it's 8, right? So let me I need to write some code just to obtain the model's predictions. So let's say model dot predict, right? Let me use this one, uh, images underscore test, and let me define I minus 1, colon I, the entire range, and we have to convert the predictions to the probabilities, right? So let me say it as PREDI is predictions equals to this one, okay, and PROBABI probabilities equals to TF dot NN dot softmax, because softmax is the activation function which deals into the probabilities, right? And we have to pass it as predictions, right? Dot numpy, right? And the probabilities which we are getting here we have to convert into the percentage. So probabilities equals to probabilities into 100, right? And we have to create a bar chart to plot the probabilities for each class. So let's say plt dot figure, and let me define fig size equals to some let's say 14 by 6, right? And plt dot bar, here we have to define the x input. X axis equals to 1 2 3 4 5 6 7 8 9 and 10, right? And height equals to probabilities of zeroth, right? And let's say tick labels, tick underscore a label equals to same as 0, 0, then 1 2 3 4 5 6 7 8 and 9. Why only 9? Because we started tick level by 0, and from here the x-axis we started by 1, right? Now let me execute this cell. Okay, this is little bit more, so instead of 14 let me make it as 12, and let me reduce it for, okay. Now you can see here the model predicted label as 8. So what is the confidence for 8? It says the 100% it is the 8. Now let me do some other, let's say 39, it says 5, right? 5 also, label was also 5, and let me execute the next one, and it says for 5. 5 for 5 score is 100%, so model is 100% confident that the predicted is the 100% 5 digit. So we have to do some check on this one, like 26, so 20 says 3, right? 26 says 3, and the score for 3 is also 100%. So let me say 34, so for 37 level is 7, and here you will see this plot says, because it's a little bit kind of tilt, right? So it's predicted as 7, but here in the plot model says it's only 60% 3, and it's around nearby 18%, it's a 7, and 12% is 1, 20% is 2, and 2% is 4, and sometimes it's 8 and 9, because it's in a little bit tilt, okay? So the arc which is coming on this number 7, this is confusing to the model, so model got confused here, so that's what it predicted more compared to this one. Okay, so instead of 34, let me do 340. It says 2, and what is the about this one? This is 100%, right? So this is about the digits prediction, guys. This is all the end-to-end solution using the convolutional neural network. We have trained the model, we have defined the number of epochs, early stopping the callback function, and the validation data which we use the 10% of the training one, right? And the optimizer which we use as Adam. And accuracy is matrix equals to accuracy. So thank you so much guys for watching, and I will request you to just download this Excel sheet from your end and do your hands-on by your own. So you will get to familiar with each and every component those are used here, right? And you will see the outcome here. So how the handwritten digits recognizing by the model, how accurate it is, right? So thank you so much once again for watching. Thank you.